We'll start again. So, good afternoon, everyone. My name is Amit Kumar. I'm a PhD student in ISC Bangalore. I will be your TA for the course Mechanics and Control of Robotics Manipulators. So today I will be discussing about previous year's questions of week 2. So mostly these questions will be based on the DH parameters, which you have studied in week 2 content of the course. So without delaying, let us start today's session. So the first question which we'll be looking here is this: in a prismatic joint, what are the kinematic parameters constant? So when we talk about DH parameter, so if you talk about DH parameters, there are two types of parameters we actually look into. One is link parameters, and the second one is joint parameters, right? So here we are talking about in a prismatic joint, what are the kinematic parameters constant? So if you know, if you draw the links, suppose this is a link, right? So if these are the joints, now suppose this joint is a prismatic joint. So prismatic joint means uh, prismatic joint. So that means that you can have the displacement along the z-axis, right? So it's a translation, and the rotational joint means you have to rotate the link around the z-axis. So here the z will be allocated for this joint. If this is a prismatic, the z will be allocated along this direction. Suppose this is zi. So and these links will be going back and forth, right? That will represent the prismatic movement or this displacement. So in that case, what are the constants? So as we know in DH parameters, we have what alpha I minus 1, AI minus 1, then we have DI and theta I. So sorry. So we know that alpha I minus 1, A minus 1, DI and theta I. In alpha I minus 1 and AI minus 1 are geometric. So that depends on geometric. So that does not that will not change in even if with the prismatic joint. So this will be constant, right? This will be also constant. Now we come about DI and theta. So DI is actually represents what? The it represents the joint and joint distance, right? So here the joint distance will be changing, like because this due to this prismatic joints rather than the angle of these two. That means that the frame which are here and here, this frame distance will be changing. So that represents represented by DI. So this will be variable because as this is a prismatic joint, and this will be again constant because the frame which will attach here or here, the orientation will not change. Rather, the distance between this frame will change based on the movement of this joint, which is prismatic. So the only thing which is variable is DI, and other three are constants. So the constants are, so this is link twist, link length, and what is this? Joint angle. So the correct answer will be second. Right. So let us move to the next question. So the next question is that dash is the distance perpendicular from I minus 1 frame to I frame measured from xi minus 1, right? So again, if you talk about the DH parameters, uh, we have like four parameters, and those are alpha I minus 1, and then we have A minus 1, AI minus 1, then DI, theta I. Now for alpha I minus 1 and A I minus 1, we know we measure this with respect to xi minus 1, and these two with respect to zi, right? So we are here. The question is that distance or from I minus 1 frame to I frame measured along xi. So what we want the measurement along xi. That means we want this thing AI, right? Because this is the angle and this is the distance which is measured along xi, and that is nothing but this two. If these are z1 and z2, the distance between these two is given by AI minus 1, or along, and this is x I minus 1, or here x1 as we are taking z1. So So what we want, so what should be the answer for this question? This should be the link length, right? So the correct answer for this is link length, as we want the distance between I minus 1 frame to I with respect to xi minus 1. Now moving on to the next question. Next question is we have that dash is the angle between zi minus 1 to zi measured about x-axis. Again, if you write, we have alpha I minus 1, we have ai minus 1, then di, theta I. So if you look here, these are the two related to xi minus 1, and these are the two related to um, sorry, zi, right? Now here they're asking that what will be the angle between zi minus 1 to zi measured about x-axis. So this means we are we are looking for these two measurements. Now here we are looking for the angle between zi and zi minus 1. That means we are talking about alpha I minus 1, and the alpha I minus 1 is what? This is link twist angle. So the correct answer for this question will be link twist angle. Right. So let us go to the next question. So this question is like for a given condition, frame B is rotated about the fixed frame x-axis by alpha. What will be the transformation matrix of B with respect to frame A if these two are initially coincide in coincide in all manner? So let us visualize this question. So for a given condition, the frame B is rotated about the axis, and they are saying that these two are initially coinciding. So let us take two frame. So let us take this. This is uh, this is X, this is Y, this is Z. Right. So as they are talking about two frame, let us take it as XA, YA, ZA, and then they are saying that this the second frame is initially coincide with the A frame. That means B coincides with the A frame initially. So the B frame will be also like this. So XB, YB, ZB, right? Because initially they are coinciding. Now the question asks that the frame B is rotated about the fixed frame A. So let us draw this scenario. So we have XA, YA, and ZA, right? So question is that B is rotated along uh, x-axis. So we are rotating B along this. So if you rotate B along this, what will happen? The xp will not change, right? Because we are rotating around it. So xp will be same as the x-axis. So it will be coinciding with the x-axis. And here there will be change of alpha angle in YA, or sorry, YB and ZB. So this will be the case. So this is YB, ZB, and XB will be same as XI. So now we have to find this transformation. So the transformation matrix which will be given given in this option. So if you want, so finding a transformation matrix, that means whatever rotation we have gone from A axis to the B axis, we want to come back from B to A so that it coincides in all sense like earlier. So for that, what have you done to get this configuration from here to here? We have rotated with alpha along what? X-axis, X of A, right? So let us write the transformation matrix. So we know that in transformation matrix, we don't have any translation, right? So the translation part is not there. Only one rotation is there. That is also along x-axis. So the translation part is generally given the last column. So it will be 0, 0, 0 because there is no displacement in X, Y, and Z, followed by 1 here. That is what, and this also will be what? This also will be 0. Right. So this much is clear. Now we are talking about the around x-axis. So here it will be 1. Again here will be, sorry. Here again it will be 0. It will be 0. Here 0, 0. Now we are talking about the rotation about x-axis. So one way we can look at is that what will be the reflections of YB in YA? That will be the rotation, right? So YB, if you take, that will be YB cos alpha in YA. That all we want. So so this represents X, this represents Y, this represents Z, and this is the last one is just to make it uh, uniform. So the x projection of this will be what? 0, because there is no projection in x because x are coinciding. So this is 0. Similarly, this is 0. And then in y, if you consider this one, this y projection of this axis YB is what? Cos alpha. So here it will be C alpha or cos alpha, and then sine alpha in ZA. So this Z will be what? Sine alpha. And then if you talk about this thing ZB, so if you take ZB, so this is what? Cos alpha in ZA. So here you can write this is Z component, so cos alpha, and sine, and in y direction what we can see. So if you take this is cos alpha, this is what? Sine alpha, ZB sine alpha, but YA is positive this side, so it will be negative. So what will be this? This will be minus sine alpha, right? So this is the correct answer which we are looking for. The another, so this we find using the projection. Another way to find is that if you know that if for x, if we rotate around z, the rotation matrix comes here. For x, it comes here, and then we can directly put this cos alpha minus sine alpha cos alpha. And if it is around y, it comes here, 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 and here. Right. In that also, if you remember those things, then also you can directly write this. It's better to go with the projection matrix so that you can easily visualize and comprehend the answer. So here is the correct answer which is available here. So 1 0 0 0 cos alpha minus sine alpha 0 0 sine alpha cos alpha 0 0 0 1. So this is the correct answer which we are looking for. Now with that, let us move to the next question. So question 5 here, the question is that in a non-standard DH method, the actuation force which is exerted at joint I is same place at its coordinate frame. So if you remember, if you have gone through the lecture of week 2, there are two things like which professor talked about. One is non-standard and is standard DH, right? So in both methods will give the correct results. So one can use any one of them. The standard DH will have everything in the terms of I, whereas in non-standard we have two parameters in terms of I minus 1 and 2 in terms of I. So that's why it is called as non-standard. But however, it gives a sense that if we have two frames, suppose A and B, we can this non-standard DH actually gives the sense that then how we can go from A to B uh, following a certain transformation. So that's why we in this course will be using non-standard transformation or non-standard DH parameters, right? So in non-standard DH parameters, the actuation force which is exerted at joint I, they are asking, right? So here we considered about, suppose this is 2, and this is joint, right? And suppose this is Z, is the same place at its coordinate frame as well. So actuation force, actuation means here if there is a motor, we want to give some torque, so it will try to rotate, is exerted at joint I. So here whatever so this is ZI, and the actuation is also given here itself, the same place as this coordinate frame. And we, for our sake of simplicity, generally attach our frame here, right? This coordinate frame. So that is means that the actuation force which is exerted at joint I is the same place at this coordinate frame. So that is correct. So the correct answer for this is this one. First one is that is true. So actually the actuation force exerted at joint I is the same place as that of the axis which we allocate. Uh, that is the same place at joint, at joint. So the correct answer is true for this question. Now the next question is that again there is a true and false question. Here the statement is while performing successive translation and rotation, we can change the order or sequence of homogeneous transformation. So what do you think? What will happen? So suppose again, if you take an example, we have X, Y, Z, and then if we do first rotation around these, followed by rotation around these, followed by rotation around these, and if you do in another way, in opposite, so if we do first, we'll do along these, then along these, then along these two will not give the same result, right? You might have been known about this. You can also try this using, or if you take an object and try to do uh, this transformation along different axes and try to do the uh, same type of transformation starting with some different orientation, and you will find that these two will not match. So that means that the correct answer for this is false. Now, let us move to the next question. The next question is that if we have two vectors which are orthonormal, then which of the following options is correct, right? So now if we are talking about orthonormal means these two vectors have a angle of 90 degree, right? So suppose we have vector A and vector B, then A is perpendicular to B, right? So if A is perpendicular to B, so A dot B is only given by what? Mod of A, mod of B, or the magnitude of A, magnitude B, cos alpha. That means angle between A and B. So as you know that these two vectors are given as orthonormal, that means angle is what? 90 degree. So then we have what? A, B, cos 90. Now we know cos 90 is what? 0. That means this will become 0. So what will happen? This A dot B is 0. So what does that A dot B is? A dot B is nothing but the dot product between two vectors. So when this two vectors are orthonormal, that means that the dot product is 0. So the correct answer is the dot product is 0. So you can look into this from here. So the dot product is 0. Now moving on to the next question. Now we have uh, a very good question. So triangle ABC with coordinates. So the coordinates of this triangle is given and is rotated about z-axis by 90 degree. And then they're asking whether what will be the next or the changed orientation of the triangle, or what will be the coordinates of the triangle after the rotation, right? So as if you're looking at the coordinates, let us first draw the initial configuration of this triangle. So suppose this is X, this is Y. Oh, no need of Z as we are talking about only 2D here. So this is X. So A is what? A is origin as 0, 0. Then B is 3, 0. So somewhere here 3, 0. So this is B. So this is AB, and C is 3, 4. So 3, 4. So this may be 3, 4 if you write. So this is C. So if you look at here, what we have a right angle triangle because this 3 and 3 and this makes a 90 degree, right? Now, and this is A, this is B, this is C. Now they're saying that this triangle, that ABC, which we have drawn here, is rotated about Z axis at A. So this is A. And so let me draw this. So this is Z axis, right? So we are rotating around Z. So if you rotate around Z, this whole triangle will move, rotate around this plane, or rather it will be in XY plane, but it will rotate like this, right? So what will be the position after rotation? So let us draw it here. So this is Z, we are rotating around Z. So this whole thing, this AB will come where? Here, right? After rotating 90 degree, because this is 90 degree, right? So if it rotate, this will come here and this will go somewhere here. So we'll get something like this after rotating 90 degree, right? So what we have, AB will go here. So this will come B will come here. So it will become what? So the length will not change, right? Because we are doing only rotation. So the length is 3. And if it is coming here, so what will it become? It will become 0, 3, because here this is what? Y-axis. And this is x-axis. So the x-axis it is 3, 0. So y-axis what will become? It will become 0, 3. And again, this length will also not change. So this length. So this length is what? 4, because this is the same. So this will be 4. So that means in x direction it is 4. So this will be what? -4, because we are taking this minus of x. This after rotating it will go to minus, and this will be what? 3, right? Same height. So this B is 0, 3. B becomes 0, 3, and C becomes -4, 3, and A is same as 0, 0, because we are rotating around it. So there will not be any change, as we have also looked into one of the question earlier. So this will be the configuration after rotating 90 degree, right? As it has been asked in this question. So what we'll get? We'll get A as 0, 0, B as 0, 3, and C as -4, 3. So which option has that? So A is 0, 0, B is 0, 3, and C is -4, 3. This one, right? So this is the correct answer for this question. Now moving on to the next question. So we have question number 9, that if the Z I minus 1 and Zi axis of the manipulator frames are non-intersecting ones, then which of the following option is correct? So if the Zi minus 1 and Zi axis of manipulator, right? So we are talking about uh, Zi minus 1 and Zi manipulator. So let us draw an example. So suppose there is this is Zi minus 1, and we have something here, and here is Zi, right? So these are two are non-intersecting, and so in this case, but when we look into for DH parameters, but what is in the rule that if these are this the xi should be allocated in the common normal of Zi and Zi minus 1. So what will be the common normal? So this will be the common normal, and that is xi minus 1. So xi minus 1 is the common normal to Zi minus 1 and Zi axis in that case. So the correct answer for this question is xi minus 1 is the common normal for Zi minus 1 and Zi axis. Right. So this is the correct answer. Going to the DH parameters rules, or the DH rule. Now going to the next question, question number 10. This is the second last question for today's session. So here we have that like find the link twist angle for the given frame arrangement as shown in figure. So let us again draw this. So we have this thing here 2. We have frame number 2 or joint 2 here. And we have joint 1 here. This is Z1 and this is X1, right? Okay. So what we have to find the link twist angle alpha I minus 1. Now for DH parameter, what all we have alpha I minus 1, AI minus 1, DI, theta I. Now here we want alpha I minus 1, so we don't have to look into this. Now alpha I minus 1 is measured with respect to what? Xi minus 1, right? So Xi minus 1 in this case is what? The X1. So we have to measure angle with respect to X1. Right. Now we have to find that angle with respect to x1, so that if you rotate z1 along x1, it will align with the z2, right? So and that angle is what? Nothing but the link twist angle. So this is x1 and we have to find. So we have to rotate z1. So if you see here, if you rotate z1 by 90°, it will come parallel to this, right? So this will be z1. And again, if you rotate by 90°, it will come here. And again, if you rotate 90°, it will come here. And if you do so what we do, we do rotate by pi by 2, pi by 2 plus pi by 2, 3 times, it will become parallel to z2. So that is what we want, right? And that is represents the twist angle. So how much is twisted with respect to z2, or that parameter. So here we will get what? 3 pi by 2, right? The other way around to look in. So if you rotate by 3 pi by 2, we'll get z1 parallel to z2. Another way of getting z1 parallel to z2 is minus pi by 2, right? So rather than going anti-clockwise, 3 pi by 2, go clockwise, minus pi by 2. That is also the option. So, but here we are only looking for the positive angle. That means counted anti-clockwise. So here with respect to x1, if you count anti-clockwise, z1 need to be turned by 3 pi by 2. 3 pi by 2 become parallel to z2. So the correct answer will be 3 pi by 2. Right. Now let us move to the next question. So here we have find the link twist angle and the link length for the given frame arrangement as shown in figure. Okay, so let me erase this. Okay, so let us again draw this figure here. Better understand. So this is Z2, this is 2, this length is K, this length is L, this is X1, this is Z1, this is 1. Right. So the question is find the link twist angle, right? So link twist angle means what? We have to find alpha I minus 1 and link length means AI minus 1. That means these two are the parameters which are measured with respect to xi. Sorry, xi minus 1. So here xi minus 1 is nothing but x1. So we have to measure with respect to this x1. So now if you see here, this x1 is what? This is the common normal of z1 and z2. So if you take this z1, z2, and this is z1, the common normal is x1, right? Now first let us look into the alpha I minus 1. Now alpha minus 1 is the angle by which we have to rotate z1 to get z2 along xi minus 1. That means x1 here. So zi is this one. So if you rotate by 90°, the anti-clockwise direction, like this one. So we'll get what? So with respect to x1, if you rotate, we'll get z2. So if you rotate 90 by 90°, you'll get something like this. This z1 will become like this. And in that case, z1 will be parallel to z2. So all we need to rotate by what? 90°. So that will be our alpha I minus 1. Right. So now we have alpha I minus 1, our first parameter, which is 90°. That is nothing but pi by 2. Now we have to find the link length. So link length is nothing but the perpendicular distance between Z1 and Z2 measured along x-axis, xi minus 1. So here we have x1. So what is the distance between Z1 and Z2 here? So that distance is nothing but that is the distance between along this x1 axis, and this x1 axis is parallel to what? K. And so that means this length will be same as that K. So A minus 1 will be what? Equal to K, because that is the only distance between this Z1 and Z2 along x-axis. So a minus 1 will be k. So the parameters which we're looking at is alpha I minus 1, which is nothing but pi by 2, and a minus 1, which is nothing but k. So this is the correct answer for this question. So the correct answer is pi by 2 and k. Right? So these are the questions which were given last year for the assignment. Hopefully, I have answered all these questions, and I'm hoping that this discussion will be helpful for you for this year's assignment. So some of the questions are very much aligned to this type of questions, and so you will be able to solve those questions for this year. So with that, uh, today I'm finishing today's session. So we have discussed all the questions, almost all the questions of last year's assignment. In case if you have any doubts, you can write in the chat box. I will wait for 2 minutes before ending, and we can again meet on next Sunday, 3 to 4 for week 3 assignments. And this is the QR code for this YouTube channel where I will upload this video or discussion. You can watch it there later on yourself. And if you have any doubt, you can comment it there, and I will try to answer that doubt in the next class or there itself, if it is possible. So with that, let me thank all of you for hearing me out. Thank you. We'll meet again.
Sir, hello.
Hello.
Sir, please explain the triangular sum, sir. After 90-degree, how the triangle sir turns, sir? Can you explain once
Okay.
again that one?
Okay. Yeah. Fine. Okay. So let me go to that question again. So are you able to see my slides, right?
Oh, yes, sir.
Okay. So let me draw it here, somehow here. So suppose if you take x-axis and y-axis, and you can see that question is A is 0, 0. That means what? This origin, right?
Yes,
And
sir.
B is 3, 0. So it will be here, right? And 3, 4. Sorry. Wait. And 3, 4 will be somewhat here. So if you draw, this is the triangle initially which is given, and this is C, this is B, this is A. This much is clear, right?
Oh, yes, sir.
Okay. Now what it has been asked that for this triangle, this is rotated about Z axis. So this is if XY, if you go with the right hand rule, the Z will be pointing this way, right? So we are rotating around Z. That means around Z near A axis or at A axis. So this, if you're rotating here, this whole thing will rotate. This triangle will rotate in this frame. That means in XY frame, right? And Z will be same. So let me draw it here again. This is X, this is Y, this is Z. So if you rotate, so the length will not change, right? So the AB length will be same as that, whatever initial, because we are just rotating. The triangle, the configuration will not change, right? Only in this coordinate frame, this position will change of this coordinate. So earlier we have a length of 3 here and we are rotating by 90 degrees. So this means this line will also rotate by 90 degree in the triangle, right?
Yes, sir.
So this AB will now come to where this AB will be coming here on y-axis. Earlier it was on x-axis because this is what 90 degree, and this BC will be this thing. This will be BC. So A, B, and C. Right. Now this is 3. Right. So this is 0, 0. So what will be this? 0, 3. Right. And
Yes,
this
sir.
is of length 4. This is of length 4. As you can see here, 3, 4 and 3, 0. So this will be what? Of 4. So we are going 4 in the negative x direction, whatever frame of reference we have taken. So this will become what? -4, because we are talking about we are looking with respect to this x-axis. So this is in opposite direction. So this will become -4, and the y-axis is the same as what we have at b here, because these are the same. So this will be 3. So this will become -4, 3. And this will be 0, 0. So now it becomes 0, 0, 0, 3, and -4, 3. Right. So that's why I said this. The first one is the correct answer. Understood?
Thank you, sir. Clear, sir. Clear.
Okay. Okay. Thanks for asking. So anything else? Okay. So I don't think that we have more questions. Okay. So you're asking the location at which a coordinate frame is attached to a rigid body in a multi-response strategy convection, sir, is convection is where? So generally we attach to this joints where there is a joint. So we generally try to attach the frame there itself, right? Hello. Okay. So if there are no more questions, so we'll end today's session here. We'll meet again next Sunday. In case if you have any doubts regarding this discussion, I will be uploading these slides. You can find on my YouTube channel. You can also find it from the course announcement session, from where you can get this YouTube link. And there also, if you go through this discussion, if you have any doubt, you can comment it in the YouTube channel itself. I will try to answer it there, or else I will try to answer that question in the next